So in this question, it's asking you to use moles calculations. This is an AO3 question because it's asking you to apply that to a reaction of phosphorus and sodium hydroxide, a reaction that you've never seen before. So it's testing, are you aware which moles equation to use, and then how to combine the different moles equations together. So the first thing it's asking you is to calculate the total volume of phosphine gas in centimetres cubed that can be produced at room temperature and standard pressure. Now, because you know in the question that you've got room temperature and standard pressure, you know that you can use N equals V over 24, but that's going to give you an answer in decimeters cubed, and it's asked you to calculate the volume of gas in centimetres cubed in the question, so I need to convert those decimeters cubed into centimetres cubed by multiplying by 1000. But before I can work out the volume of gas given off, I need to work out how many moles of phosphorus I started off with. And since I've got 1.86 grams of phosphorus, P4, in the equation, I know I can use N equals M over R Fm. That's my equation. I know the atomic mass of phosphorus is 31, so therefore I know the molecular mass of P4 is 31 times 4, which is just 128. So my number of moles is 1.86 divided by 128, which gives me 0.0145 moles. I know the ratio of my phosphorus P4 to phosphine pH3 is 1:1 because the stoichiometric coefficients in the equation. Therefore, I can just rearrange my N equals V over 24,000 equation to get N V equals N times 24,000, which gives me an answer of 348.75 centimetres cubed. Now, it's not specifically asked me in this question, but it's normal to give answers to three significant figures, so I've rounded that to 349 centimetres cubed. And the second part of the equation is asking you to give a balanced equation for an unfamiliar reaction where phosphine's burnt in oxygen. It tells you that the only products are water, which you know has the formula of H2O, and an oxide of phosphorus P4O10. So I know that I'm starting off with one phosphorus in pH3, but I'm ending up with 4 phosphoruses in P4O10. Therefore, I need 4 lots of the phosphine molecule. Okay, that means that I'm ending up with 12 hydrogens on the left-hand side of my reactant side. Therefore, I need to multiply my waters by 6 to get the 12 hydrogens, because in each water there's 2 hydrogens. That means I've now got 6 oxygens from the water and 10 from the P4O10. That gives me 16 oxygens in total. So therefore I need to multiply my 2 by 8 to get 16, so I have 8 lots of oxygen. So my balanced symbol equation is 4 lots of pH3 plus 8 lots of O2 reacts to give 4 P4O10 and 6 lots of H2O. In the next part of the question, it's asking you why Na3PO4 that is formed on reaction of phosphoric acid with the P4O10 with water is an example of a salt. Well, it's an example of a salt because it's made by reacting the phosphoric acid with sodium hydroxide, so it's a neutralization reaction. And we know that the product of any neutralization reaction is salt and water. The amount of moles of H3PO4 in 15 centimeters cubed of 0.1 moles per decimeter cubed. I know that in this case the phosphoric acid is a solution, and therefore I have to use N equals CV. I've been given the volume in centimeters cubed, so I therefore need to convert that into decimeters cubed by dividing by 1,000. So I've got n equals 0.1 times 15 divided by 1,000, which gives me 1.5 times 10 to the minus 3 moles. In the next part of the question, it's asking you to calculate the volume of sodium hydroxide that reacts with exactly 15 centimeters cubed of 0.1 mole per decimeter cubed phosphoric acid. Well, I know from my equation that 3 moles of sodium hydroxide reacts with 1 mole of phosphoric acid. So I've got a ratio of 3 to 1. So therefore my number of moles of sodium hydroxide is 4.5 times 10 to the minus 3 moles. So I can rearrange the N equals CV equation to make V the subject by dividing both sides by C. I know in my question that C is 0.2 moles per decimeter cubed. So I've got 4.5 times 10 to the minus 3 divided by 0.2, which gives me 0.025 decimeters cubed. But note the units in the question are asking for you in centimeters cubed, so you need to times by 1,000 to go from decimeters cubed to centimeters cubed, which gives you 22.5 centimeters cubed. In the next part of the question, it's asking you to explain the different boiling points of hydrides. The first thing you need to notice is that the ammonia, NH3, has a hydrogen bond, but the phosphorus hydride has a dipole-dipole. Because there is a significant difference in electronegativity, but remember, only nitrogen, oxygen, and fluorine can make hydrogen bonds. So therefore there's no hydrogen bond possible in the phosphine. So that explains why the melting point and boiling point is higher in ammonia than it is in phosphine. Because in phosphine, yes, you've got stronger London forces because there's more London forces in phosphine because the atomic number of phosphorus is higher than the atomic number of nitrogen. But in nitrogen, you've got a hydrogen bond.